Lesson 5, finding absolute value and adding real numbers. The absolute value of a value is the distance from the number to 0 on a number line. Oftentimes we get this confused with the negative or positive. You think opposites, and that's not the way it goes. We have to always remember that absolute value is the distance from 0. So, for example, it says the absolute value of 4, which is written with the absolute value bars that we see here. Okay, we see that 4 is right here. Let me change to a pen instead of my cursor. Okay, so we see that 4 is right here, and negative 4 is over here. They both have the same absolute value because they're both 4 units from 0. So 4 from 0 to 4, I have 1, 2, 3, 4 units. From 0 to negative 4, I have 1, 2, 3, 4 units, which gives me an absolute value of 4. So on these, all it wants us to do is find the absolute value of each of them. The absolute value of negative 5 is the distance that negative 5 is from 0. That is 5 units. The distance that 3.9 is from 0, that would be 3.9 units. And then we have problems like these, where we have something inside, we have a problem inside of the absolute value. Well, whenever we have this, we have to simplify everything inside before we can find the absolute value. So if I have 2 minus 1/3, 2 minus 1/3 is going to give me 1 and 2/3. And I still want the absolute value of that, which is still going to be 1 and 2/3, because 1 and 2/3 is 1 and 2/3 away from 0. Over here, we're going to do the same sort of situation. We have 17 plus 24 inside of the absolute value. So we're going to do 17 plus 24. 17 plus 24 gives us 41. Bring down our absolute value symbols and that negative that's on the outside. So the absolute value of 41 is 41, but we haven't used that negative, so we have to bring it down. This is a case where we're going to have a negative because the negative was not inside of that absolute value. Rules for adding real numbers. Whenever we are adding numbers with the same sign, we add their absolute values and give the same sign as the add-ins. So for example, if we have 4 plus 5, the absolute value of 4 is 4, the absolute value of 5 is 5. And so we have 4 plus 5 gives us 9. These are both positive numbers, so 9 is a positive number. Over here, we're adding two negative numbers, so we have to add their absolute values. The absolute value of negative 4 is 4, plus the absolute value of negative 5 is 5. 4 plus 5 is 9, but we have to keep the sign that the numbers had. So we're going to get negative 9. Adding numbers with different signs, we find the difference of their absolute values and give the sign of the add-in with the greater absolute value. I don't know why I have these weird spaces here. That's been the way it's saved. So whenever we have different signs, we're going to find the difference of the absolute values and then give the sign of the add-in with the greatest absolute value. So here I have 3 plus a negative 2. 3, the absolute value of 3 is 3. The absolute value of negative 2 is 2. So I take 3 minus 2 is 1. And then I have 3 and 2 for the absolute values. And 3 has the greater absolute value. Its sign is positive, so the 1 was a positive. Over here we do the same thing. Negative 3 has an absolute value of 3. 2 has an absolute value of 2. Since they're opposite signs, we're going to take the difference or subtract them. I have 3 minus 2 is 1, But once again, negative 3 has a greater absolute value than 2. So this 3 is negative, which means our answer is negative. Okay, something else that I'm going to tell you. In my classroom, I do not like to confuse things any more than that we have to. So anytime that you see double signs here, I have plus and negative, I am okay with you circling those signs and saying opposites gives me a negative. So here we would have 17 minus 52, which is going to give us a negative 35. This would still be true if we did it with our rules. The absolute value of 17 is 17. The absolute value of negative 52 is 52. And if I take 52 minus 17, that's going to get me that 35, but the negative has the larger absolute value. Here, same thing. This one now, I have the same sign. Whenever we have the same sign, we add the absolute value, keep the sign. So these have the same sign. The absolute values would be 4 and 31. 4 plus 31 is 35. My answer is going to be a negative. I would like for you to do C and D on your own paper, and we will talk about those tomorrow. Example 3, it says the set of whole numbers is closed under addition. This is stuff that we talked about a couple of days ago. I think it was like lesson 1 or 2. The set of whole numbers is closed under addition. That means that if I take any two whole numbers, I add them together, my answer will have to be a whole number for it to be true. So whole numbers, let's remember, are the set of counting numbers or natural numbers and zeros. So we have 0, 1, 2, 3, 4, 5. It keeps going. And that looks like the ellipse on there. Okay. So if I add any two of these numbers, am I always going to get a whole number? Let's think about it. 0 plus 2, that gives me 2. 2 is a whole number. 2 plus 4 gives me 6. 6 would be a whole number. This is going to be true. On B, true or false, the set of natural numbers is closed under subtraction. Remember that natural numbers is another name for counting numbers, which is 1, 2, 3, and that keeps going. Okay, so if I take, let's say, 5 minus 2, 5 minus 2 gives us 3, we know that. But what if I switch these two numbers around? 2 minus 5, what does that get us? Well, that, you should know, gets us a negative 3. Is negative 3 a counting number? No, negative 3 is an integer. So this one would be false. This is your homework problem for the night. Example 4, please do it on your own paper and have it ready for class tomorrow. Have a nice night.